Hey there, Earth Science. Hey there, Earth Science. You are going to need to get out your Northia assignment, which we started last week. And last week we came out and we talked about, like, number one, labeling the pressure belts and wind belts on the map. And we started to think about what climates would be caused. And you're using your climate notes and then your break and wind notes. So we have this hypothetical continent called Northia, and you'll see that there's a whole bunch of cities located. So what we want to do is we're going to kind of break up and we'll go over the answers. Make sure you guys are on the correct path. So let's look at the number two. It said city A, what type of climate? So let's actually, even before we start filling this out, let's look at city A. So we have city A right here. It's at 0 degrees latitude. So we know strongest rays are hitting at 0 degrees. So what we've got, sun heats the earth, earth heats the air. The air gets really hot, right? So that warm air rises, and we know that that warm air rising is going to bring our low pressure system. Therefore, we have that huge amount of precipitation. That's why we see at that equatorial low, you've got your rainforest. So based on that, let's go back through and answer some of these questions for city A. What type of climate? So hot and wet. And why? All right, so we know at that 0 degrees is our equatorial low. So we have a large amount of precipitation. Our average temperature, remember, if you guys, average temperature is high, and actually if you can even refer back to your climate notes, you will see that climate graph that we did for the climate notes at the equator, that you do have that high average temperature, high amounts of precipitation, and that there was no range. Because why? Which kind of answers our next question. Why? We have strong rays and long days. So temperature range low, and why? Because there's no range, because there is no change in rays and days. All right, so no range because there's no change in rays and days. All right, so now let's look at number 3. For number 3, we're looking at city B. So city B still at 0 degrees, but the difference now is that city B is at the top of the mountain. So 3,000 meters, about 9,000 feet. Compare its climate to city A in terms of temperature range, and why. So even if I went back to my climate notes, we talked about elevation. And if I've got here at the equator, remember, this is the climate graph essentially that we just did, right? So high temperature, high amounts of precipitation, no range, because there's no change in rains and days. But then if I looked at that second example, when we were 7,000 feet above, you're going to have a lower average temperature, because if you remember, even back to when you did the layers of the atmosphere project, as you were increasing in altitude in that thermosphere, there was a decrease in pressure, therefore decrease in temperature. So we have a lower average temperature at that higher elevation. In terms of range, though, you'll notice that the range is going to be the same, because you've got the same amount of rays and days at that 0 degrees latitude. All right, so now let's go put that same information into our problem. So our average temperature, we're going to say lower. And why? It goes back to our example. We increase altitude. We're going to decrease in pressure, and therefore temperature. So my temperature range, low, and why? Same thing that we had above here for city A. They're both at 0 degrees. There's no range. because there's no change in rays and days. All right, so let's do our climate graph. So in terms, I think we use green for our temperature. So city A is going to have a higher temperature. City B would have that lower temperature. Average is going to be high. So I'm just kind of doing this right on top of that line. This is going to have a lower average. So just going to write high average here. And this would be a lower average temp. In terms of precipitation, so remember we had high amounts of precipitation. Equatorial low. Sorry, guys, that's my 12 months. And then in terms of range, we're just going to say there's no range. And again, that goes back to there's no change in rays and days. All right, as always, I'm sorry, you cannot see that. That gives you guys a second so you can copy that down. As always, if you have any questions, please reach out to me or Mr. Bowsy. Thanks, guys.